Hello everybody, welcome to the online course Basics of Microprocessors. In today's world, the microprocessors play a very important and vital role. As all of you know that today's human beings cannot live without a computer. Then the next question is, what is inside a computer? Most of the people know that inside the computer there is a processor. More frequently we use the word Intel processor. Then what is the meaning of this processor? Or what is the meaning of the microprocessor? Today's lecture is on the basics of microprocessor. But before going to the details of microprocessor, let us first understand clearly at the basic level what we exactly mean by a microprocessor. Afterwards, we can go to the details of microprocessor. From the point of a dictionary, what is the meaning of a processor? A processor is a device which do some processing. What is the meaning of processing? Processing means activity. Processing means activity. So, or which performs some work. For example, if we take a domain related to mathematics, what is the meaning of processing in terms of mathematics? Doing some multiplication of a given data, or arranging numbers in ascending order, or arranging the numbers in descending order, or finding the square root, or solving a quadratic equation, etc., etc. So then we say some processing is done with respect to mathematics. Suppose you go to an office and you submit an application. Then the person in the office says that he is processing your application. What is the meaning of that? He will be checking or verifying the details, and he may be preparing a draft or writing a reply or doing something related to your file or your application. So if you consider an electronic processor, then what it will do? It will perform various arithmetic or logical operations, or sometimes control operations also. For example, if you take a electronic circuit which can perform some mathematical operations, what is that? All of you know that it is your operational amplifier. But when I use the word microprocessor, micro means it should be small. So it should be small in size and it must perform various operations. Microprocessor. But when you consider your operational amplifier circuit, especially in discrete circuit, what do you see there? You see a very big circuit of this. You can see here. When I consider, only to make you understand, I have taken this example. A single operational amplifier will have nearly 25 to 30 of transistors, some resistors, sometimes capacitors, so many things. So this will be your discrete operational amplifier circuit. This can perform some mathematical operations. As you know, operational amplifier or op-amp can act as a multiplier, a divider, an integrator, an adder, or a scale changer, or integrator, or a differentiator. So all these mathematical operations are performed or processed with a given data. But can you use this as a processor? No, it's not as an advisable thing. Why? Because it occupies large space. Therefore, what people have done in order to create a processor of small size, they have used the concept of integrated circuit. As you know, the first integrated circuit was designed by Jack Kilby at Texas Instruments in the year 1958. When I consider this single circuit, so when I consider this, I call this as integrated circuit. When I consider large number of thousands or more than thousands of gates or transistors on a single chip, then it is called VLSI technology, very large scale integrated circuit technology. Very large scale integrated circuit technology, VLSI, very large scale integrated technology. What it will do, in a single chip you may have thousands and thousands of transistors, or you can say gates. So by definition, microprocessor means a processor of very small size. Hence, Intel started using this VLSI technology to produce the first 4-bit microprocessor in the year 1970. The first microprocessor of 4-bit was given by Intel Corporation or Intel Company in the year 1970. It was based on VLSI technology. Now we have understood why we use integrated circuits. Integrated circuits occupy very small space, whereas discrete circuits, as you see, they occupy large space. If I say here this is a discrete circuit for the same operational amplifier discrete circuit, I can have an IC. I have shown here IC 741. Some of you might have done some lab or theory in your earlier years. IC 741. This is an operational amplifier IC 741, 8-bit IC. So these are examples for IC. That means once you come to IC, the size of the circuit becomes smaller and smaller. But when you come to VLSI IC, this becomes much smaller. Therefore, what do you mean, or how do you define this microprocessor IC? It is a very, very small integrated circuit which can perform wonderful processing. Therefore, Intel started producing the microprocessors in the year 1970. The first was a 4-bit microprocessor. That's why. And at the same time, the IBM started using microprocessors in the digital computers. People realized the power of microprocessors and they started using which is the first company? IBM, International Business Machines. First company started using the microprocessors in their computers. Earlier, the size of the computer, digital computer, was also very, very large. But with the advent of these microprocessors, the size of the digital computer was also reduced. Let us see. So, how do you define the microprocessor? The microprocessor is defined as a programmable logic device. It can be programmed, follow some logic. Programmable logic device that can process arithmetic, logical, and control operations at very high speed. That's most important, and it is fabricated using VLSI technology. So I suggest every one of you to remember this word VLSI technology, very, very important. Or a microprocessor can also be defined as it is a multi-purpose. That means it can be used for many purposes, for arithmetic operations, logical operations, control operations, etc. That's why we say multi-purpose. Programmable, it can be programmed. Whereas your IC741 operational amplifier, IC555 chip, timer chip, they are not programmable. But this is a programmable logic device which reads the binary instructions, binary data from a storage device called memory. That means your microprocessor will read the data from memory and it will perform some operations processing on this input data and give the suitable output according to the instructions that you have written. This is very, very, very important. They based on the instructions that you have written. Normally people call a set of instructions is called program. Therefore, what is your microprocessor? Microprocessor will take the binary instructions or binary data from the memory, and based on the program that you have developed, it will give the results as output. This is the basic idea of or principle of your digital computer. Therefore, how do you define a microprocessor? In another way, a microprocessor can also be defined as the heart of a digital computer, because without this microprocessor, the computer cannot process anything. Without a microprocessor, the computer cannot process anything. So, to understand further, what I'll do is, I'll show the block diagram of a simple digital computer. Let us see. So what do you have here? A computer, that is, you have a CPU. All of you know that CPU means central processing unit. Now, in terms of electronics, what is the central processing unit? Because this is a central processing unit. Who will process according to your electronics? So far, it is nothing but your microprocessor. Therefore, people also define microprocessor as a central processing unit. Where it gets the data? It gets the necessary binary data from your memory. So here I have shown the memory device. And how it gets memory data from memory to CPU? Through some bus, that is some connection, electrical connection. If it gets the data, it is called data bus. If it gets the address of the memory, it's called address bus. If it gets the control signals, to transfer the control signals, I use a control bus from the CPU. And this is your I/O device. There may be many I/O devices. To enter the data, I may require a keyboard, I may require a mouse, I may require any device like a pen drive, that is an input device. I use a monitor to display the data, that is an output device. So I/O devices are here, but all are connected to the CPU externally with the help of data bus, address bus, control. If you have a single line, it is called only if I use a single signal. It is a line. If I have something like 8 lines, something like this, 1, 2, 3, 4, 5, 6, 7, 8. So that means I can send 8 bits of data at the same time parallelly. So this is called, what do you call this? This is called a bus. So when I have multiple bus, so I am not able to write correctly. So this is a bus. So here when I write like this, so when it carries data, it will become data bus. When it carries address, it becomes address bus. When it carries control signals, it will become control bus. So what is a digital computer? A digital computer is nothing but a CPU, and externally you have a memory, I/O devices, and other peripherals also. We will come to this afterwards slowly. You will learn everything. But how you connect them? With the help of address bus, data bus, control bus. So with the help of buses, we do this. Therefore, what is your microprocessor? Fundamentally, what you have to understand today, a microprocessor is nothing but simply CPU. So how do you get a digital computer? A microprocessor along with the memory, along with the I/O devices and all peripherals which are connected through some lines which we call bus, forms the digital computer. Hence, many people define the microprocessor as also the CPU or the heart of the computer. I repeat again, a microprocessor is also, it's an electronic device. It's an electronic chip. It is a VLSI chip, which is nothing but, or which acts as the CPU of your digital computer. So in this introduction class, you have to understand what is a microprocessor. It's an electronic chip. It's a VLSI electronic chip. You can use many definitions. What it will do? It's a processor. It can perform various activities like arithmetic, logical operations, control operations. This is also, or this leads to a new concept called ALU, arithmetic logic unit. That's how you get this unit ALU, which we'll discuss in the next coming classes. At present, you understand that a microprocessor is nothing but the CPU, or a microprocessor is nothing but the heart of the computer, or in terms of electronics, a microprocessor is a programmable logic device which can perform various arithmetic, logical, control operations by taking the necessary inputs from the memory and gives the output, suitable or expected output. But how and where, how it started? So that is, who has given this first microprocessor? As I told you in the earlier slide, Intel is the company. Intel introduced the 4004 first microprocessor to the worldwide market on November 15th, 1971. It was a 4-bit PMOS chip. You'll understand this MOS devices, that is P-type metal oxide semiconductor chip with 2300 transistors. I have told you, when I say VLSI technology or large scale integration, means it consists of large number of transistors on a single chip. So at that time, 1971, a 4-bit microprocessor, first microprocessor was a 4-bit microprocessor. What do you mean by 4-bit microprocessor here? When I use the word here, 4-bit means it can process at any instant of time, that is in one clock cycle, it can perform 4 bits of data. That means in digital electronics, you will understand bit means either 0 or 1. 2 bits means either 0, 0, 0, 1, 1, 0, 1. Similarly, 4 bits means any value between 0, 0, 0, 0 to 1, 1, 1, 1 at that. So around the same time, Texas Instruments developed also a 4-bit microprocessor called TMS1000 and became the owner of microprocessor patent. They have taken the patent. Later, Intel produced the world's first 8-bit general purpose microprocessor. This is all chronology, or you can say evolution of microprocessors, how the microprocessors have evolved into the market. So to explain these things, what I have done, in the next slide, I have given a table where you can understand really what are the companies, what is the name of the microprocessor, in which year it has evolved, and how many number of transistors it has. So what was the first microprocessor according to this? So the first microprocessor was Intel 4004. 4004 was the Intel 4-bit microprocessor, which was released in the year 1971. First 4-bit microprocessor. At the time, it was 2300 transistors only. Of course, nowadays it is obsolete, totally outdated. We don't get these processors. Only to understand the evolution, we try to see these details. Similarly, after that, it has released 8008, then 8080. At the same time, another company called Motorola has also given one 8-bit microprocessor in 1974. That's why I told you, not only Intel, there are other companies also like Motorola, Zilog, similarly Philips. Similarly, there are so many companies like Texas Instruments, as you have seen. So many companies are in the field, but Intel is a dominant or almost the leader in this field of microprocessors. So then Zilog was also given an 8-bit microprocessor, which is termed as Z80. Z80 means it's a 8-bit microprocessor. MCR Motorola 6800 was also an 8-bit microprocessor in 1974. After that, Intel gave a 8-bit microprocessor, which has become very popular in those days, or even now also students consider this as an academic standard. 8085 8-bit microprocessor. This was given in the year 1976, which had 6500 transistors and which used to work at 5 megahertz. Of course, there is also other earlier version which uses only 3 megahertz. So you consider this afterwards. So now let us consider the other things. So where we'll have the next, after 8-bit, in 1978 we got 16-bit microprocessor. It's also known as advanced microprocessor 8086. At the same time, in 8088 they were used the first IBM computer in those days, that is during 1979 and 80. So after that you got Motorola 6800 also. After that Intel has given 8186, then 8286, you can see the dates, years, and then 8386. It was the first 32-bit microprocessor, which was a powerful. So in those days the IBM has used this in their computers like PCs. They used to call this as PC, as you know. Today also personal computer, PCXT. In their PCXT computers they used to use during 1985. It was 8386, first 32-bit processor. So then in 89 they have released 8486. So they used to call this as, in those days I remember, IBM PC 80. 80 means advanced technology, XT means extended technology. In those days we used to call this as XT means extended technology, 80 means advanced technology. After that there were so many changes in the IC technology. Then Intel released, instead of using the word 586 after this, they have not used the word 586. It means penta. That's why they call this as Pentium 1. It's a kind of 8586 processor. They have given some. After some time they have called this as 8586. The next version is Pentium 2, Pentium 3. In this you have also seen some processors called Celeron processor, Pentium 3, Pentium 4. So this was a very popular in those days, in the year 2000, around 2000. This was a very popular processor, Pentium 4. After some time, they have started releasing more powerful processors during 2002, Xenon 64-bit. From 32-bit, they have come to 64-bit. You also observe that with respect to this, the number of transistors on the chip is increasing. Also, the clock frequency is also increasing. So you can see here from megahertz they have come to gigahertz. So you see here all the frequencies are 8 to 20 megahertz, 6 megahertz, 6, 10, 12 megahertz. Mega means 10 power 6 hertz. So after this slowly megahertz, so by the time it has come to Pentium 4, it has come to nearly 1.4 to 2 gigahertz. Giga means 10 power 9. So after this, nowadays we have Core 2 Duo. We have seen next Core 2 Duo with 64-bit. Next version Core i3, Core i5, as you know, Core i7. Majority of the desktops, laptops, they use i7. Of course, recently 2018 and 2019 we have now Core i9. This is also 64-bit. There will be multi-core processors have come slowly. So some other time you will understand what is a multi-core. 10 or most of the mobile applications we use deca-core, means 10 cores. So a processor with the 10 cores, that means so with very high speed of nearly 5 gigahertz. 5 gigahertz speed, high speed. So we have so many advanced processors which are used for many applications. But to understand these things, to understand these processors, you have to know the first processor, basic processor, and how it has evolved. That's why here I have given or tried to make you to understand the meaning of the 4-bit microprocessors and 8-bit. So if you go once again, what is the meaning of 4004 4-bit microprocessor? That means this 4-bit microprocessor can process only 4 bits of data in one clock cycle. So the clock cycle time mainly depends on the frequency of the clock of the processor. So 4 bits means, as you know, 1, for example, 1, 0, 1. This is a 4-bit data. So if you want to do addition, subtraction, multiplication of such data, so this 4-bit data can be, or any operation can be performed in one clock cycle. Suppose I want to perform 8-bit data, then the same 4004 processor will take 2 clock cycles, because for 8. Suppose I want to perform 32-bit data processing, then I require how many? 8 clock cycles. Therefore, this 4004 was very soon modified 4-bit into 8-bit, 16-bit, 32-bit. That's what we have seen now. because for high speed. So Intel started producing high speed processors like 8-bit, 16-bit and 32-bit. Why? Because a 4-bit means low speed, 8-bit is also low speed. But when I say 32-bit or 64-bit means it is a high speed processor. Therefore, along with the Intel, as I have told you, what you should remember, companies like Zilog, Motorola, AMD, Philips, so many companies started producing microprocessors. Though there are many companies, still Intel is considered as the leader in this market. Therefore, whenever you see, normally whenever you come across processor or microprocessor means majority of the market deals or remembers the Intel. So this is about the basic idea and the evolution of the microprocessors. Once you understand this in your syllabus, in order to understand the advanced processors in future, we will take up the Intel 8085 microprocessor. Here I have shown the chip. So this is your Intel 8085 microprocessor chip. This is basically a 40 pin chip. You can count the number 40 pin. Here you can see Intel 1976. It was given in the year 1976. This chip. This is Intel 8-bit microprocessor was released in the year 1976 March. But very interesting thing, but nowadays it is not available, I told you. But in the year 2000, Intel has stopped the production of 8085 because it is obsolete, outdated. Only for students' sake we'll consider it, because to understand the microprocessor, the easiest thing is 8-bit 8085 microprocessor. Either industry or in the market, you don't use this microprocessors, only for academic standard, only to understand subject for students in schools, colleges, universities. Still people are using this or trying to understand the basic processor, architecture of this basic processor, so that it will become easy for them in future. So I considered the first one. So this 8085 processor was available in 2 clock versions. Earlier it was 3 MHz and then it became 5 MHz. This was 80. They used to call this as 8085A, and then they used to call this as 8085-2 second version. Mostly people started using second version. The 8085 is considered as almost an academic standard, as I have told you. So it is available in as a 40 pin. There are 40 pins, you can count here. There are 40 pins. It is a DIP chip. So whenever you have an IC, when you have dual inline on both sides along the line, you have the pins. So this package is called dual inline package. It's called a DIP, 40 pin DIP chip, and it works at plus 5 volts DC supply. Remember, Intel 8085 microprocessor works at plus 5 volts DC. It is a 40 pin IC, VLSI chip IC, and it's available in, what is this most important thing, this is called DIP chip, dual inline chip or package. So once you have understood this, once it is an 8-bit processor, what is the meaning of this 8-bit processor? 8085 can process 8 bits of data in 1 clock cycle. In 1 clock cycle, this is very, very important. How do you get this clock cycle? This clock cycle depends on the operating frequency or crystal frequency of the microprocessor. We come to this while studying the architecture in the next classes. So one of the parameters that decide the speed of the microprocessor is clock. It is only one of the parameters, not always. There may be many other parameters, but the clock frequency is also equally very, very important. That means when you consider a 5 MHz, then a 10 MHz processor is more faster than 5 MHz. Similarly, 10 MHz, 20, 30. That's why we have the processors of 5 GHz. I told you from megahertz we have moved to gigahertz. Gigahertz means much faster. So because we know that the time of execution, you know the basic principle, the time t is equal to, that is time of execution t is equal to, all of you know that t is equal to what? 1 by reciprocal of frequency. So as this f is increasing means, t is decreasing. That is time taken for execution will decrease, or it can execute more number of instructions in a clock cycle. When this F is in gigahertz, means it can take only nanoseconds of time. That's why the latest processors or computers can execute some thousands and thousands of instructions in one clock cycle. That's why they are considered as the fastest. That's how the speed will increase. Of course, at this level you may not require. This may also have some what you can call bad effects. That is, the power dissipation may become high. We'll discuss this in future. But at present, you remember that the clock frequency of the microprocessor is very, very important. Another thing is how it is important. It is going to synchronize the activities of the microprocessor with the clock frequency. That's why the frequency operation is very, very important. So, to understand all these things, what we have to do, you have to understand the architecture of the microprocessor. So the architecture of the microprocessor is very, very important. So we will consider the architecture of the microprocessor in the next coming class, and till then you remember all the details of the basics of the microprocessor, such that in the next class this will become easy for you to understand the architecture of the microprocessor. So in this class you have learnt what is a microprocessor, what is its importance, how a computer is formed, and what are the various definitions of the microprocessor, etc. Okay, so I wish you all a good luck. Thank you.